Welcome to the deep dive. Today we're diving into something kind of sci-fi sounding.
Oh, yeah.
Cold start data.
Okay.
And, it really is a key thing when you're talking about these big, these large language models, LLMs.
Right.
Especially when you bring in something called reinforcement learning.
Yeah. Those are really kind of fundamental to the cutting edge of AI.
Now, the deep dive today is going to be based on a research paper.
Okay.
It's called DeepSeek R1, Incentivizing Reasoning Capability in LLMs via Reinforcement Learning
Right.
from DeepSeek AI.
Okay.
And one of the things that we're going to get to a little bit later is that they talk about this aha moment
Interesting.
that happened during their development, and it really does sound like something straight out of a movie.
Okay.
But before we get to that, let's kind of back up and unpack this idea of reinforcement learning.
So reinforcement learning, or RL, is a really powerful way to train machines, especially LLMs.
Okay.
And it's very similar to how we humans learn through trial and error.
Yeah.
So imagine you're learning a new skill, like playing the piano or something.
Mm-hmm.
At first, you're going to make a lot of mistakes, but you get feedback. You adjust and you get better.
Yeah.
Same basic principle.
So are you saying that with reinforcement learning, we're basically letting the model just go out there and experiment
Exactly.
and learn from its mistakes, just like we as humans do?
Yeah, so in the context of LLMs, they receive these things called rewards when they produce the desired output.
Okay.
And these rewards, they reinforce the behavior that we want to see, leading to improved performance over time.
That's really interesting. So you're kind of almost treating it like a pet, but instead of treats, you're using data and algorithms.
That's a great way to put it.
Now let's dive into this DeepSeek R10, which is actually the predecessor to DeepSeek R1.
Okay.
What makes that particular model stand out?
So what's really interesting about DeepSeek R10 is that it was trained solely through reinforcement learning.
Wow.
No initial fine-tuning or anything like that. It was just a blank slate learning everything from scratch.
Interesting.
And they used a specific type of RL algorithm called Group Relative Policy Optimization,
Okay.
or GRPO.
GRPO.
Yeah.
That sounds pretty complex. Can you break that down a little bit more for us?
So GRPO, it's basically a more efficient way to do reinforcement learning.
Okay.
It doesn't require a separate critic model.
Okay.
It directly compares different versions of the model's behavior
Interesting.
to see which one is better and
Right.
then focuses on improving in that direction.
So it's kind of all about efficiency.
Yeah, you could say that.
Now, you mentioned these rewards before.
Yes.
What kind of rewards are we talking about here with this model?
So with DeepSeek R10, they use two main types of rewards: accuracy rewards and format rewards.
Okay.
Accuracy rewards are pretty straightforward.
Right.
Basically, the model gets a reward if it produces the correct answer.
Makes sense.
Format rewards, on the other hand, are about how the model presents its reasoning process. So the researchers, they wanted the model to express its thoughts in a really structured way.
Yeah.
So they rewarded it for following a specific format.
So it's not just about getting the answer right. It's also about explaining how you got there
Exactly.
in a way that people can understand.
Yeah.
Now, that's really crucial, I think, if we want these models to be useful tools for us.
It is, absolutely.
And this is where it gets interesting. They observed something really remarkable as DeepSeek R10 was learning.
What's that?
They noticed that the model started to actually dedicate more processing time to problems that were challenging.
Wow.
It's as if it was pausing to think,
Like a human would.
just like we do
That's incredible.
when we're faced with a difficult problem.
Yeah.
So it sounds like it was almost like it was developing its own learning strategies,
Right.
even without being explicitly programmed to do so.
This self-evolution of DeepSeek R10 during training was really key to the creation of DeepSeek R1, which incorporates something called cold start data to further improve its learning and reasoning.
So this cold start data sounds like a game changer.
It is.
But before we get into that,
Right.
maybe let's just pause here for a second and give our listeners a chance to absorb everything
Sounds good.
that we've covered so far.
All right. Welcome back to the deep dive. So before the break, we were talking about DeepSeek R1.
Yeah, we were about to jump into this cold start data and its role in developing DeepSeek R1.
Right.
You know, that self-evolution that we talked about with DeepSeek R10, that was just really eye-opening.
Yeah, it's pretty remarkable.
Made me even more curious about this cold start data.
Well, let's get into it then.
Okay, so what is it?
So cold start data is basically a set of really high quality examples that we give to the model before we even start the reinforcement learning.
Okay.
It's kind of like if you were teaching a student, how to solve a problem, you might give them a few solved examples first.
All right, so instead of letting the model just figure everything out from scratch, we're kind of giving it a bit of a head start like a teacher.
Exactly. It's like providing some initial guidance.
Okay, so this cold start data, it sounds like it has a big impact on the model's performance.
It really does.
How does it work? I mean, does it help the model learn faster, or is there something more to it?
It's not just about speed. We talked about how DeepSeek R10 had some issues with readability and how it presented its reasoning.
Right, right.
Well, cold start data kind of addresses that directly.
So are you saying that by exposing the model to good examples of well-structured reasoning, like before we even start the reinforcement learning, we're basically setting it up to communicate more clearly?
That's exactly it. We're giving
Yeah.
it a framework for how to think and express its thoughts in a way that we can understand.
So it's more human readable.
Exactly. And that's really important for real-world applications.
Yeah. I mean, if we can't understand what the AI is trying to tell us, what good is it really?
Exactly. And that's why they incorporated this cold start data into the training of DeepSeek R1.
So how did that work? Did they just like add this data to the existing RL process?
They actually use a multi-stage training process.
Oh,
The first stage was fine-tuning the model with this cold start data,
okay.
and that kind of gets it on the right track.
So they're kind of layering the learning process then.
You could say that.
They're starting with this foundational layer of cold start data and then building on that with reinforcement learning to really improve its reasoning abilities.
Yeah, that's a good way to think about it.
Interesting. So the training didn't stop there.
No, it didn't. Once the reasoning-focused RL was almost done, they actually used a technique called rejection sampling to further refine the data.
Rejection sampling. I haven't heard of that. What is that?
So it's a way to filter and curate the data that's used to train the model.
Okay.
So they basically looked at all the data that had been generated, and they selected only the very best examples, the highest quality examples.
Wow. So they're really making sure that the model is learning from the best possible information.
Exactly. And then that refined data was used for the final stage of fine-tuning.
So it sounds like they really went to great lengths to ensure that DeepSeek R1 was not just a powerful reasoner, but also a clear communicator.
They did, and the results were really impressive.
Well, yeah.
DeepSeek R1 ended up significantly outperforming its predecessor, DeepSeek R10, on all sorts of reasoning benchmarks.
So incorporating cold start data and refining that training process really helped them create a model that's not only smarter, but also easier for us to understand.
It's a great example of how seemingly small changes can lead to big advancements in AI capabilities.
That's incredible. Now, there's one more thing I want to ask you about.
Okay.
It's this idea of taking the knowledge from a large, complex model like DeepSeek R1
Right?
and distilling it into smaller, more efficient models.
Oh, yeah. That's a fascinating concept. It's kind of like taking all the knowledge of a master chef and putting it into a simple recipe that anyone can follow.
Exactly. So they took all of that training data that they had for DeepSeek R1, those 800,000 examples we talked about,
Right.
and used it to fine-tune smaller open source language models like Qwen and Llama.
That's right.
How did those smaller models perform? Were they able to keep up with the big guys?
You might be surprised to hear that even those smaller distilled models achieved really impressive results on reasoning tasks.
Wow, that's really exciting.
Yeah.
So even if you don't have the resources to train a massive model from scratch,
Right.
you can still achieve really good results with these smaller, more efficient models.
It really opens up the possibilities for making AI more accessible to a wider range of people.
This has been a fascinating deep dive. We've learned about reinforcement learning, cold start data, this knowledge distillation. It's a lot to take in.
It is a lot. Maybe we should pause here for a second.
Yeah, let's give our listeners a chance to process all of this information.
Sounds good. We'll be back in a moment to wrap things up.
Welcome back to the deep dive. It feels like we've really gone deep, haven't we?
We have covered a lot of ground.
Reinforcement learning, cold start data.
Yeah, and it's all very much at the forefront of AI research right now.
Before we wrap up, let's take a second to kind of summarize what we've talked about.
Okay, sure.
For me, one of the most mind-blowing things is just the power of reinforcement learning as a way to train these models.
It's really amazing how you can train a model to think strategically just by rewarding it for the right behaviors.
Yeah, and remember how DeepSeek R10 figured out how to adjust its learning strategies all on its own.
Right. It's like it was adapting to the difficulty of the problem.
That whole aha moment thing they talked about in the paper still blows my mind.
It does make you wonder just how much these models can learn without us having to explicitly program them.
And then we have cold start data, which is another key takeaway.
Yeah, giving the model just a handful of really good examples can make a huge difference.
Not just in how well it performs, but also in how well it communicates,
Right, it's like we're providing it with a foundation of good reasoning to build upon.
instead of just throwing it into the deep end and hoping for the best,
And that leads to outputs that we as humans can actually understand and use.
which is kind of the whole point, right?
Exactly. We want AI to be a tool that we can work with.
And let's not forget about that knowledge distillation
Well,
thing.
yes. Taking all that learning from the big models and transferring it to smaller ones.
So we can potentially make advanced AI more accessible to more people.
Exactly. Even if you don't have a giant supercomputer, you can still benefit from these advancements.
It's exciting to think about what the future holds for AI.
Definitely, we're just scratching the surface.
It's kind of a bit daunting too, though, isn't it?
It is. There's a lot of responsibility that comes with this technology.
But for now, I think we've done a pretty good job of demystifying some of these concepts.
Hopefully, our listeners have a better understanding of how these things work.
Well, I want to thank you all for joining us on this deep dive.
Yes, thank you for listening.
Keep exploring, keep asking questions. And until next time, happy diving.